Okay, so in Chapter 3, we're going to look at a little bit of probability theory. We're not going to spend a lot of time here in Chapter 3, but we just need a little bit of this background when we get to Chapters 4 and 5. So a rare events rule says, rare piece of steak, right? Rare event rule. Well, the rare event rule says if under a given assumption the probability is very small, then the assumption is, and the event occurs, then the assumption is probably not correct. If something's very rare, it probably will not happen. But let's look at some definitions for probability. First, an event is a collection of results or outcomes. A simple event is an event that can not be broken into simpler components, so there's only one outcome or one result. A sample space is the collection of all the possible simple events of a procedure. For notation, P stands for probability, A, B, and C, etc. are events, and the P of A is the probability of event A occurring. The relative frequency approximation of probability is based on observed values. So we observe the number of times that A occurs, and we divide that by the number of times the trial was repeated. So for example, a basketball player has made 30 of his 50 attempted free throws. Estimate the probability that the player will make the next free throw. Pause the lecture for just a minute and answer this problem. Okay, so you did 30 divided by 50 and you got 0.6. So about a 60% probability that he will make his next free throw. The law of large numbers says, even though the probability of flipping a coin and getting heads is about 1 out of 2, so 1/2. But if we flipped a coin twice, it does not mean that we'll get 1 head and 1 tail every single times we flip a coin twice. The law of large numbers says, as the procedure is repeated more and more and more, the relative frequency approximation tends to approach that actual probability. So if we flip a coin 1,000,000 times, we expect to see about half of them being heads and about half of them being tails. That's the law of large numbers. Not if we flipped a coin twice, will we always get 1 head and 1 tail. The classical approach to probability needs to have each of the probabilities need to be equally likely to occur. So if a given procedure has n different simple outcomes, each of which is equally likely, and an event A can occur in s different ways, then the probability of A is s over the n different outcomes in the sample space. Now, pause the lecture for just a minute and answer the question. If you choose a card at random from a regular deck of cards, I'm sorry, that's a typo there, you do not roll a deck of cards. What's the probability that you get a 7? Pause the lecture, and remember that in a regular deck of cards there are 52 cards, 4 of which are 7s. So pause the lecture and answer this question. Well, 4 out of 52, which is the same thing as 1 out of 13, would be the probability that you would choose a card and get a 7. Subjective probability is an educated guess. That's what your doctor does when he says the probability that your surgery will be successful is 80%. Or when the weatherman says the probability of rain tomorrow is 30%. Those are educated guesses. It's not based on data, but it's based on the education of the guesser. We have certain special probabilities. If an event is impossible to occur, its probability is 0. If an event is certain to occur, its probability is 1. So for any event A, the probability of A has to be between 0, impossible to occur, or 1, certain to occur. Complements are nice. All right, the complement of an event A is denoted A bar, consists of all outcomes in which A does not occur. The probability of A complement is equal to 1 minus the probability of A. So the rules of complementary events is the probability of A plus the probability of A complement is certain to occur, because either A occurred or A did not occur. So it's one of those two is certain to occur. So when you add those probabilities, they must sum to 1. which means we can find the probability of A if we know the probability of A complement, because it would be 1 minus the probability of A complement, and vice versa. So now, find the probability that a randomly selected individual was not born in September. Ignore leap years, and pause the lecture for just a minute and answer this question. So there, 67 divided by 73 is the probability that they were not born in September, which means what are all the other months, other days out of the year that that were not September. So to be 1 minus the 334 days that were not September. So the rule of thumb says for probabilities, either you leave it as a fraction or you round to 3 decimal places. All right, that is the end of part 1 for chapter 3.